Here we have a SAT math problem. Okay, let's go to the question. The sides of an equilateral triangle are shortened by 12 units, 13 units and 14 units respectively, and a right triangle is formed. Find the length of the side of equilateral triangle. Okay, let me draw an equilateral triangle over here. Okay, now we can consider this one as an equilateral triangle. Since it's an equilateral triangle, all the three sides will be equal in length. Let me assume x as the length of each side of the equilateral triangle over here. According to the question, we have to find the length of the side of equilateral triangle, that is the value of x. So now we have to find the value of x. And now let's consider the other information, that is the sides of an equilateral triangle are shortened by 12 units or 13 units or 14 units. Okay, now let me take this is the first side of the equilateral triangle. When this is shortened by 12 units, then the new length will be x negative 12. And now let's consider this is the second side of the equilateral triangle. When this is shortened by 13 units, the new length is x negative 13. When I shorten the third side by 14 units, the new length will be x negative 14. Now, these are the sides of the right triangle, because the question says when the sides of the equilateral triangle are shortened by 12 units, 13 units, 14 units, and a right triangle is formed. That is, these lengths will form a right triangle. Okay, now let me draw a right triangle over here. Here I've drawn a right triangle. We have right angle over here. Then this is the hypotenuse because it is opposite to the right angle. Now, in these three lengths, we have to identify the hypotenuse. Okay, which one can be the hypotenuse? We know that in any right triangle, the hypotenuse is the longer side. So, the greatest of these three values will be the length of the hypotenuse. Okay, how do you have the greatest of these three values? Okay, when I consider the first one, we have decreased 12 from x. The second one, we have decreased 13 from x. And in the third one, we have decreased 14 from x. In all the three cases, we have decreased different values from the same value x. Now we have to consider the one where we have decreased the smallest value from x. So this one. So this will be the greatest among these two values. So this x negative 12 must be the length of the hypotenuse. And we can take this one as the length of the one of the other two legs. Let me take it over here. And this is the length of the third leg over here. That is x negative 14. Now we can apply Pythagorean theorem over here in this right triangle. So that is the square of the hypotenuse x negative 12 the whole square equals to sum of the squares of other two legs, that is x negative 13 the whole square positive x negative 14 the whole square. Now we have to solve for x in this equation because x represents the length of the side of equilateral triangle. Okay, now we can go to Desmos and solve for x in this equation. Let me give the equation as input, that is x negative 12 the whole square equals to x negative 13 the whole square positive x negative 14 the whole square. Okay, here I got the graph of the given equation. Now let's consider the two x-intercepts. The two x-intercepts, let's consider the x-coordinates over here 13 and 17. The two values of x are 13 and 17. Okay, here we got two values for x. We know that x represents the length of the side of an equilateral triangle. Which one do we have to consider, 13 or 17? We know that the sides of the right triangle are x negative 12, x negative 13, x negative 14, and this x negative 12 represents a hypotenuse. Now let's plug in the first value of x, that is 13 over here in all the three stuff over here. 13 negative 12 is just 1, and 13 negative 13 is 0, and 13 negative 14 is negative 1. Okay, when I plug in x equals to 13 in the sides of the right triangle over here, I am getting 1, 0, negative 1. So 0 cannot be the length of one of the sides of the triangle, and also negative 1 will never be the length of one of the sides of the triangle. Always the length of the sides of a triangle will be positive. So this first value of x, that is 13, will not work. So we can reject the first value of x. Now let me verify the second value of x, that is 17. When I plug in x equals to 17 over here, 17 negative 12, I am getting 5. When I plug in x equals to 17 over here, 17 negative 13 is 4. And when I plug in x equals to 17 over here, I am getting 3. Okay, I am getting 3, 4 and 5 as the sides of the right triangle. And it's possible because these three values can be the sides of the right triangle because it will also satisfy the Pythagorean theorem, that is 3 square positive 4 square equals to 5 square. That is the sum of the squares of two legs equals to the square of the hypotenuse. Therefore, the length of each side of the equilateral triangle is 17 units.